We're going to find the shear and bending moment diagram for this question. The first step is to draw the reaction forces. At point A, we have a roller, therefore we have one force, AY. At point B, we have a pin, therefore we have two forces, BY and BX. BX is equal to 0 because there are no external forces in the X direction. The second step is to calculate the concentrated force for this uniformly distributed load. 3 kip per feet times 6 equals 18 kip. The next step is to find the reaction forces. We're going to sum the forces in the y direction. We have negative 18 kip plus AY plus BY equals to 0. Since we have two unknown reaction forces, we need a second equation. So we're going to sum the moments about point B. The first term is 18 kip, and the distance is going to be 9 plus 3, half of 6, which is going to be 12. Since this is going in the counterclockwise direction, this term is going to be positive. Next, we have AY times the distance to B, which is 9 feet. Because this is going in the clockwise direction, we're going to have a negative term, equal to 0. And AY equals to 24 kip. We're going to use this value to determine BY. Negative 18 plus 24 plus BY equals 0. BY equals negative 6 kip. This negative value indicates that the value we've assumed for BY is incorrect and it should be in the opposite direction. Now that we have the reaction forces, we can draw the shear force diagram. We're going to start at 0. And since this is a concentrated force, which is a value of 18, we're going to go from 0 to negative 18. Because it's a uniformly distributed load and it has a horizontal line, we're going to go to our line order chart and see that the next line is going to be sloped. So it's going to be this shape. And there is an AY value here, which is positive 24. So we're going to go up 24. It's going to give us a value of 6. There's no external forces, so it's going to be constant. And B is going to be negative 6. So we're going to go down. And that's the shear force diagram. The next step is to calculate the areas, A1 and A2. So A1 is going to be 1/2 base times height, which is equal to, our base is 6 feet, and our height is 18. And the value is going to be 54. We're going to do a similar calculation for A2, which is going to be 54. And now we can draw a bending moment diagram. We're going to start with 0. Since this is below 0, we're going to have a negative value. So negative 54. Because this is a slope line, we're going to have a parabolic shape. And we can have this shape or this shape. Because we have a larger shear at this point when compared to this point, the slope at this point must be greater than this point. So the slope of this line right over here is 0 here, and it's steep here. Therefore, we know that that is the correct shape. Next, negative 54 plus 54 is going to be 0 because this is above 0, positive, and we have a uniform shape here, which is a horizontal line. Therefore, this next line is going to be sloped, and we're going to connect this And this is the bending moment diagram. Thank you for watching. Please like, share, and subscribe.